Consider the following specification. Write a program that asks users to enter their percentage mark for a module of study. The program prints the module grade as either distinction, merit, pass or fail, depending on the percentage mark entered. A mark of 70 and above is awarded a distinction. So for example, 70, 71, 72, 99, 100, all of those marks get a distinction. A mark in the range of 60 through to 69 is awarded a merit. 60, 61, 68, 69. A mark in the range of 40 through to 59 is awarded a pass. And marks less than 40% are awarded a fail. 39, 38, 0, all of those would be awarded a fail. Before we attempt to write a program to meet this specification, it's important that we fully understand what the specification is asking us. And one of the best ways to achieve an understanding of a specification is to produce a test plan before you start writing code. Now repeat that, before you start writing the code. And that's what I'm going to do here. I'm going to produce a test plan, and then I know that when I finish my program, I can test it against the plan that I produce, in the knowledge that the production of the test plan will aid me in my understanding of the specification. To aid me in my understanding of the specification, I've produced this number line, onto which I've marked 0%, 40, 60, 70 and 100%. Now the ones I'm interested in are these here. These are the boundaries for my problem, 40%, 60% and 70%. Because this is where when I hit 40 I know I'm going to get a pass, when the input is 60 I know it's going to be a merit, and when it's 70 I know it's going to be a distinction. So these are my boundaries, and I go either side of them. I go for 39, 40 and 41 to be inputs to my program, and I need to predict what the output will be for those three values there. Likewise with the 60, I go 59, 60, 61, and I need to predict what my program will do. And here for the 70, I've gone 69, 70, 71% as my input, and here's my data, and here is my test plan. And you can see for the 69, 70, 71, I've put this here in my test plan, and you can see when we enter 69, we get the output shown here. For the percentage mark of 69, the grade awarded is a merit. When we input 70, we want the output string to be, for the percentage mark of 70, the grade awarded is a distinction. When we enter 71, we want the output to be, for the percentage mark of 71, the grade awarded is a distinction. And what I'm doing here, I'm saying what my program should be producing for each of these inputs here. So for example, when I enter 39, I want the output to be, for the percentage mark of 39, the grade awarded is a fail. I'll just choose another one. Let's choose this one here. When we enter 59, I want the output to be, for the percentage mark of 59, the grade awarded is a pass. And we can look at all of those inputs and see what strings I'm suggesting the program has to produce. Now the fact that I've produced this is helping me understand what the specification is, because I'm trying to predict what the program will produce for all of these inputs, even though I haven't started to write the program yet. Let's now consider the program to meet this specification. We can see we have a sequence of steps here, followed by a selection construct, followed by an output. If we have a look at the first line, what we're doing, we're setting up a variable called module mark to an empty string. This line will allow the user to enter something at the keyboard and will give a user-friendly prompt. And this selection construct here, we need to realize, has got 1, 2, 3, 4 possible routes through it. Which one of these routes is chosen depends upon the mark that was entered at this particular step. Now what we'll do, we'll have a go at running this program against some of the tests that were put in the test plan. Not all of them. I'll just do 2 or 3, and I'll let you then have a go at running the program with the other tests. Here you can see one of the runtimes. And we can see if this particular line of code in the program has been responsible for outputting this string here, and that the user has responded as it said in the test plan by entering 39. And of course this 39 is now stored in percentage mark. What we now need to do is to have a look at the selection construct and go to each of these tests in turn. If we look at this one, it is saying, is the percentage mark, which is 39, greater than or equal to 70? False. This one here, well, that's going to be false as well, because 39 is not greater than or equal to 60. If we come to this one, is 39 greater than or equal to 40? No, it's not, so that's false. Consequently, when all of these tests were false, we find that the selection construct we've chosen goes to the else and executes this. So the module mark is then assigned fail. We then come to this line, and this line is responsible for outputting for the percentage mark of 39, the grade awarded is a fail. Now this line consists of two literal strings here and here, which we can see is appearing here inside the print and here. And of course, this was responsible for outputting this 39, and this was responsible for outputting the fail. So we can see that the first entry in the test plan has come to fruition. This is how I predicted the program would run, and it's done it, but it's done it for the 39. We've now got to test 40, 41, and so on as outlined in our test plan. Let's look at the runtime, where this time we enter 41. So we can now go to look at the selection construct, and we're going to see where 41 actually is greater than or equal to 70, false, 60, false, 40, true. Consequently, we execute this line here. Module mark is assigned pass. And of course, we now simply go to execute this line here. And it is responsible for putting out this line for the percentage mark of 41. The grade awarded is a pass. Let's now consider the runtime when the user enters 60. Consequently, we will come here and we'll look at this selection construct, and we can see that on this particular test here, the percentage mark is greater than or equal to 60. Well, that's true, because 60, well, it isn't greater than 60, but it is equal to 60. Consequently, this line here will execute, and these will not execute, because remember, this is a selection construct, and only one of them will execute. Consequently, when we execute this line, the output we will get will be for the percentage mark of 60, the grade awarded is a merit. We can now test the program again, but this time using one of the other entries from the test plan, the entry of 71. And of course, when we go to the selection construct, we should now be able to see that the conditional test that gives us true is this one here. And consequently, we will execute this line of the code. We won't execute any of these. And immediately after we've executed this line, we go on to execute this, which we can see outputs for the percentage mark of 71. The grade awarded is a distinction. So you can see I've tested this program for some of the entries in the test plan. When you finish watching this video, I suggest you run this program and test it for all of the entries in the test plan. So here you can see where I have actually done the tests, and you can see that here I've entered 40, and I've gone either side of 40 with the 39 and the 41. I've entered 60, I've gone to 59 and 61, I've entered 70, I've gone to 69 and 71. And you can see I've got a fail, I've got some passes, I've got some merits, and I've got some distinctions as my output. And of course, all of these should correspond to the test plan that you can see here. So your role now, I think, when you finish watching this video, is to just do what I've done here and test it against all of the entries in the test plan. Before we move on, let's consider this particular program here. Here you can see I'm assigning to X0, and I'm following this now by a selection construct that we can see has 1, 2, 3, 4, 5 possible routes. Now, if we look very carefully at the tests, we can see they're all identical. They're all asking, is X equal to 0? Is X the same as 0? Well, they all are, as we can see. So all of these tests must be true. So which one is executed? Well, what we can say definitely is this one isn't executed here, because this follows the else, and this only executes when the tests here are false. But in fact, we can see they're all true. Now, as you might expect, the one that's actually executed is this one here. The first one that's true is executed. None of the others are actually executed. This is the runtime for this particular program, and we can see that these two lines have clearly been output by these two print statements that exist within the selection construct. And then we can see that the program actually ends, showing us that none of the other possible routes through this particular program were executed. Here you can see I've altered the program slightly. I've ensured that this test is false, because X not equal to 0 is clearly false, whereas these three are all true. Now, if we follow on the logic It's clear that the block that will execute will be this block here, as we can see from the runtime that appears here, and we can see that the strings here have clearly come from these print statements. Now here you can see I've altered the program again, making sure that all of these tests here are false. Now for this particular case, we're going to find that the block of code that will execute is the block that comes after the else. As you can see, the output is here. I am a string in the else block. I am also a string in the else block, and that has clearly come from these print statements here. So we can see that the else executes when all of the tests are false. Check out the supporting website for these videos and consider subscribing to the YouTube channel, and you'll get an automatic update every time I upload a new video on Python.